This ArcGIS Insights page is used to assess the station elevation and the height of snow variables. You can see we have 4 scatter plot charts here. The upper one is the average max height of snow, and then we have the 10, the 30, and the 100-year values. You should watch the data preparation video to make sense of what those values mean. But generally speaking, if I'm just looking for relationships and trends and stuff, I can pretty much just look at the average chart beside the map. If I want to actually pull statistical values, then I'm going to want to look at probably one of the bottom charts. So the main map can be used to select the points. We have all the points. Again, they're symbolized by type. So if we want to turn off snow courses, they're the yellow ones. See, they make up the majority of the points. I'm going to leave them on, leave everything on. So I found a good relationship here. I'm interested in Revelstoke, and the example I've been using is maybe I want to build a tower at 1600 meter elevation, and I don't have any good stations right at 1600 meters, so I'm maybe looking for a relationship. So here I'm selecting the points around Revelstoke and Rogers Pass. And what happens is, as I select these points, I now have close to 10 points selected. We can see all of the charts and the table station list update to just show those points. So these ones have a pretty good fit. What we have here is the equation of the line and the R-squared value. And the R-squared value is a measure of correlation. So a high value closer to 1 means that this trend line fits the points quite well. I'm just going to reset. If we look at all the points, and if we want to reset any of these charts, we can click the home button. We can see an R-squared value of 0.188. So it's not 0. It's not completely random, but it's very low score, and we can see that, right? Points deviating from the fit line like substantially. So if we are interested in a design problem, our goal is to get a good fit. We want a nice fit. We can say down here, low elevations around Revelstoke, we're seeing roughly 1 meter to 1.5 meters of snow on average. And then up in Rogers Pass at higher elevations near tree line, we're up into the 3 to 3.5 meter, and it's a good relationship. So if we were building a tower at 1600 meters, we could just go up to the line and we can read it across and pull our value. Or if we wanted a more exact value, say we're interested in the 100-year maximum height of snow at 1600 meters, we can go to this formula. And the way you read this formula is Y is the 100-year max HS is equal to 0.204 times X. X is the elevation, so we would multiply 1600 times 0.204, and then we'd add 85.2, and that would give us our 100-year max HS value at 1600 meters. If we're just loosely interested in it, we can just read up. It's a little over 4 meters, say for 410 or 420 centimeters roughly. And then if we were designing something, we could use that value. It works good if you know loosely where you have good relationships. If we're interested in doing an analysis on a region, we can click any of the regions on either of the 2 small maps. So for example, if I was interested in trends within the South Coast Inland region, this is an avalanche region that is notably variable snow climate from north to south. We can now see here we have a R-squared value of just over 0.5, so it's not a great relationship. We can see lots of points that are well below the line and some that are well above the line. And what this is sort of suggesting is that there's maybe some sub-regions within this main region that have similarities in snow climate data. There's one major limitation to ArcGIS Insights in this case, and that's that I can't customize the chart labels. So when I hover over any of these points, it shows me the type, the elevation, and the average value. These are the two data points that actually make up the scatter plot, and then the type, which it's symbolized by. There's unfortunately no way to add the station name to these labels. So what you have to do here is if you want to start to investigate these points, you can click on them. What clicking on them does is it just isolates that single point, but it shows us the name in the table above the station list. So that's Sunday Summit that I clicked. Then if we want to reset it, we can just click anywhere and then click our polygon again to get it back. I've gone through some of these points, and what I've found is if I use the select tool again and I select the cluster down here around Allison Pass, I start to see a better relationship. I found that as soon as you capture some of these points in the interior plateau region, the Okanagan, it starts to dry out. But if you collect just all these wetter ones in the mountains, we start to see a better relationship. Here we're almost at 0.9. Then we have a middle region around the Coquihalla. If we click roughly these points, we start to see a decent fit. And that's almost perfect, but that's only 3 points. And then a third cluster up here is very sensitive, this grouping. If we choose these 4 points around Pemberton, we get a decent fit. And then there's one other grouping here on the drier side of the Coast Range. When we get closer to Lillooet and Braylorne, again, we see a decent fit here, but these are drier. In a perfect world, we could take each of these lines we just showed, I think I just showed 4, and we could put them all on a graph, and we could see the difference. Each fit line is pretty good for each of those 4 groupings I just showed. Same thing works really well in the North Columbia region. If I click the North Columbia region, I get all these points. And again, you can see it's not a great fit, but we do see sort of a lower range and an upper range. And again, if you start trying to pinpoint these points, so the way to find out what these points are without actually clicking them is to hover over it, observe the elevation and the type of data, and then view it off of this list here. So 1200 is Knuff Lake. I know that's near Kamloops. We have 1312 Environment Canada. That's Sun Peaks lower. And I keep digging into this data, and again, I can click all these stations around Kamloops, and we get a decent fit. And as I keep digging go back to the North Columbia, use the select tool, and choose these ones up here around Mica. Again, we see a decent fit. There's still some variance down here in low elevation. We have one here, 1720 Adams River. So we have one that's definitely drier than the rest. But Adams River, again, is more on the foothills out here. So I may need to make a better selection just around Mica. Uh, 1890 Keystone Creek. I happen to know Keystone's I think a shorter data set, so maybe there's maybe that's dragging the average down. But you can see how we can create relationships between elevation and the different snow variables here.